पुढचं पण करायला घे.
बाकी येत नाही मला, बाकी सगळं
इलिमिनेशन बाय डिफरेन्स वगैरे सगळं झालं. आता ते टॅब नाही बघत नसेल, झोप नसेल झोप थोडा वेळ.
हे काय
Good afternoon. So today we can do a few MCQ from the first chapter. We already did some MCQ during the session. So today also we can discuss some MCQs. Okay. Don't expect I'm covering for means almost all chapter, but I can cover few. Okay. So write down the questions. Write down first question. A cylinder of radius r, small r, a cylinder of radius r and length L, small l, is placed in an uniform electric field, parallel to the axis of the cylinder, full stop. The total flux for the surface of the cylinder is given by so option 1 0, option B that is pi r square, option C e pi r square, last option 2 pi e, capital E r square. Okay, I'll repeat the question once again. A cylinder of radius r and length L is placed in an uniform electric field parallel to the axis of the cylinder. The total flux for the surface of the cylinder is given by first option 0, B pi r square, C e pi r square, and last is 2 pi e r square. Okay, so these are the options given. No diagram, so we can draw the diagram from the given information. Here we have a cylinder with us. We have a cylinder. Okay, this is what the cylinder we have. Okay, and electric field, what they are saying, going parallel, no, it is placed in a uniform electric field. Okay, uniform electric field, and moreover they are saying it is parallel to the axis of the cylinder. Okay, so electric field is like this. Okay, in this direction electric field is traveling. Even in theory part also we cover the same question. Suppose if you are taking this as a first area, okay, or first part. Now if you take this as a second part and this area you are taking as a third one. Okay, so here we are mainly focusing on the area vector, because we know that flux phi is nothing but what, E bar into ds bar or S bar. We have this. S is nothing but what, your area. Okay, so here first we have to identify the area vector for all the three different areas. So here देखो E bar is in this direction and of course its area vector is always perpendicularly outward. So here area vector is in this direction. Here E bar is also in this direction and area vector you can take here as a S. That is also okay. That is what coming in the outward direction. So if you check here E and S are what anti-parallel. That means here it makes an angle 180 degree and here E and S both are going in the same direction. That means angle theta is equal to how much here? 0 degree. So now here if you observe, check here electric field is going like this, okay, parallel to the cylinder and its area, okay, this CSA having an area and its area vector is going outward perpendicularly. So this is S bar. So angle between them is nothing but how much here? 90 degree. Okay, if you know this, then it's very easy to calculate the net flux. Correct? No, they are asking here the total flux for the surface of the cylinder is given by. So options are given. We can solve here. If we want to calculate here flux phi 1. Okay, phi 1 is nothing but what? E into S. Okay, E into S cos of 180. Okay, E into S cos of 180, that is nothing but minus E into S. Okay, this is phi 1. No need to substitute the area and all. So that we can do it afterwards. Then what is phi 2? Phi 2 is this. So here in this case Es cos of 0. Correct? Because the angle between them is 0. So here cos 0 is 1. So here we will get maximum flux. And phi 3 is nothing but what? Cos 90. Cos 90 is 0. So I will write here E into S cos of 90 and this answer we will get how much? 0. But they are not asking three different fluxes. They are asking only net flux. That is the total flux they are asking. So phi t is nothing but what? Phi 1, phi 2 plus phi 3. That is nothing but minus E into S plus E into S plus 0. So minus and plus get cancelled and we will get the answer 0. So here according to this option, option A is the correct option. Net flux from this is nothing but how much? 0. Getting this? Same theory question we did, but there we took different electric field, correct? And now here we are considering different. Maybe they will give means it is going from this side to this side. Okay, in that case also you will get 0 only. But if it is giving vertical, in that case you will get flux is different. So you must know the basic concept how and where we can apply the formula for the flux. Getting this? Understood? So option A is the first option. Many are asking me whether we need to do working or what. If you are practice more, if you are confident, then you can choose answer directly. But I always prefer go for the proper steps, solve, check what is the correct answer we are getting, whether it is matching with answer or not. And then you can choose the option. Okay, so copy this. Okay, getting this question, copy this. Now write down next question. I hope everyone is copied. So write down next question. Which of the statement is true for Gauss law? Which of the statement is true for the Gauss law? Which of the statement is true for Gauss law? First option, they are saying here first option, all the charges. First option, all the charges whether inside or outside, all the charges whether inside or outside, the Gaussian surface contributes to the electric flux. Then second option, electric flux depends upon electric flux depends upon the Gaussian surface. Electric flux depends upon the geometry of a Gaussian surface. Next, third option, Gauss's theorem can be applied. Gauss's theorem can be applied to non-uniform electric field. Gauss's theorem can be applied to the non-uniform electric field. Okay. Now, last option, write down the field over the Gaussian surface remain continuous. The electric field over the Gaussian surface, remains constant and uniform, at every point. Okay. So these are the four options. I will read quickly. So which of the statement is true for Gauss law? First option is given, all the charges whether inside or outside the Gaussian surface contributes to the electric flux. So second option, the electric flux depends upon the geometry of the Gaussian surface. C, Gauss's theorem can be applied to the non-uniform electric field. And last is, the electric field over the Gaussian surface remains continuous and uniform at every point. Okay, so we have to find out the correct option. So you can think and read each and every option properly. So first they are saying flux, we know that flux we will get when we are applying a region where that region is enclosed by the some certain polygon. Okay, so here some three-dimensional figure is there, and that field we are enclosing. So here the first is, all the charges whether inside and outside the Gaussian surface contributes to the electric flux. No, if charges are outside it will not. Okay, because we are taking we know that flux phi is equal to, we have the formula Q net upon epsilon naught. Q net means what? Q net, we are taking the charges which are enclosed within the surface area. So here outside charges we are not taking. So first statement is false. Now second statement, electric flux depends upon the geometry of the Gaussian surface. No, it depends upon the number of charges and permittivity. It does not depend on the shape, size, length and all. Okay, so second statement is also false. Then C, Gauss's theorem can apply to the non-uniform electric field. No, we can't apply for the non-uniform electric field. Non-uniform electric field means what? The distance between each electric field line is different. So if it is different, then the flux generated at every point is also different. Okay, that is not the same. So third option is also wrong here. Then only last option is there, that is electric field over the Gaussian surface remains continuous and uniform at every point. That is true. Okay, if we have a uniform electric field and we are having same, and we are enclosing the some area in the electric field, so everywhere you will get what? Some continuous flux from that region. Okay, so option D is the correct option. So mark that option as a D. Okay, so you should know basics of the flux, and when we are applying the concept of the flux, and you should know the formulas for flux. Phi is equal to Q net by epsilon naught. This is also there, and phi is equal to E into ds cos of theta. Okay, so wherever the field is given, area is given, then go for phi is equal to E ds cos of theta. And whenever the flux which is based on the charge and permittivity is there, that time you can use this formula, phi is equal to Q net by epsilon naught. Okay, getting this? Copy this question. Tick mark this option. Option D is the correct option. Okay, write down. So write down next one. Write down, if the net electric flux, if the net electric flux. Everyone is getting, those who are attended, can you able to understand? Write down, if the net electric flux through a closed surface, if the net electric flux through a closed surface, is zero, then we can infer, first option, no net charge is enclosed, by the surface. No net charge is enclosed by the surface. B, uniform electric field. B option, uniform electric field exists. Uniform electric field exists within the surface. C option, electric potential varies. From point to point, inside the surface. Last option, charge is present inside the surface. So I will repeat this question. If the net electric flux through a closed surface is zero, then we can infer, first bit, no net charge is enclosed by the surface. B, uniform electric field exists within the surface. C, electric potential varies from point to point inside the surface. And last option, charge is present inside the surface. So here again they are asking, means different option. So if the net electric flux through the closed surface area is zero, okay. So many are saying, ma'am, if the flux is zero, that maybe field is uniform, okay. So field is uniform and charges are also fixed. So that is also correct, but here we have this formula, that is phi is equal to q net by epsilon naught, okay. So q net by epsilon naught, if suppose maybe this q net will be 0, no. If q net is 0, if I have a closed area but net charge enclosed within the surface area is 0, then in that case also I am getting flux 0 only, no. Correct? So if we use this formula, so we will get here option 1. Okay, maybe no net charge is enclosed by the surface. Okay, maybe there is a no net charge, means charges are not present in this field. So q net is equal to what here? 0. If q net is 0, then ultimately 0 by epsilon naught is also what? 0. So option A is the correct option. Write down the option. Tick mark this option. Okay, so option A is the correct option. Now next write down the magnitude of electric field. The magnitude of electric field due to point charge 2q at distance r, capital R, is E, capital E. Then the magnitude of electric field, then the magnitude of electric field due to uniformly charged thin spherical shell of radius capital R, with total charge Q, Q is small, at the distance r by 2, small r by 2. And here one more condition is here, small r is greater than capital R. Okay, they are saying here small r is greater than capital R. Will be. Okay, option first, they gave here option E by 4. First option is given E by 4. Then option B is given 0. Option C is 2E. And option D is 4E. Okay. So I repeat the question. I made one mistake while dictating. That also you can correct. The magnitude of electric field due to a point charge 2Q. Okay, 2 and Q should be small, and at a distance R. Here R should be small r. That is what the correction. Small r is E. That is electric field capital E is given. Then the magnitude of electric field due to uniformly charged thin spherical shell of radius R with total charge Q at the distance R by 2, and R is greater than capital R will be. Okay, so here actually here they gave one spherical shell. Okay, this is what the center, and this distance is R. Okay, this distance is given R, and when it is at R point there is some electric field. Okay, so in this case electric field is nothing but what, kq by r square. But here q, I think they are saying there is a 2q charge is there, correct? So 2q and distance is nothing but what here, r square. Okay, no, it's distance r, small r. Distance is what, small r. So now they took one point somewhere over here. Okay, in this point I am getting new electric field, that is E dash, and this is at r distance apart. Okay, and they are saying here electric field due to uniformly charged thin spherical shell of radius capital R with total charge Q at a distance of r by 2. Somewhere here at r by 2 Q charge is placed. Okay, they are saying at some distance charge Q is placed at r by 2 distance. Okay, so here normally I am getting E is equal to 2Q upon r square, because electric field intensity we know that kq by r square. But they are saying at the beginning only the magnitude of electric field due to the point charge is 2Q is E. So that's what I took here, this charge Q as a 2Q k into 2Q upon r square, or I can write here 2kq by r square. This is my equation number 1. This is my electric field. Now at r by 2 distance charge Q is kept. In that case I am getting electric field. New electric field is nothing but what, kq, and distance is how much here, r by 2 whole bracket square. Okay, so here it will come kq upon r square by 4, then here 4kq upon r square. This is what the new electric field intensity I am getting at point r by 2. This is my equation number 2. Can you getting this? Now we can divide here equation 1 by 2. Why I am dividing? Because now I want to find out the electric field intensity when r is greater than capital R. So here we can write 1, that is, or we can divide by 2 by 1. Okay, so 2 is here E dash and 1 is E. So E dash is nothing but 4kq upon r square into, I will take a reciprocal, so here it will come r square upon 2kq. So k, q and q, r square get cancelled, 2 ones are 2, 2 twos are 4. So E dash upon E is equal to 2 by 1. Therefore, new electric field at point E, at point this is nothing but what? Twice the field of twice the original electric field. So E dash is equal to 2E. So option E is the correct option. And here many people are thinking, array here shell ka radius r is given. Okay, but they are not asking any charge on the surface, inside the surface. So this r anyhow we are not using. And here answer we are finding out in terms of electric field. So this logic we applied over here. And here we got the option E dash is equal to 2 times of E. Getting this? So option C is the correct option. So you must know how to apply what is the formula for electric field intensity, okay, what is the Coulomb's law, what is the flux, okay. In these points only this chapter is what? Jumping here and there. So questions are also nearby only, but apply whatever you learn, apply the proper and specific concept everywhere to get the correct answer. Getting this? Copy everyone. हो गया? ओके, हो गया सबका? एवरीवन कॉपीड? ओके, चलो. So write down next one. Electric flux. The next question, the electric flux through a closed Gaussian surface. Electric flux through a closed Gaussian surface depends upon the electric flux through a closed Gaussian surface depends upon first bit net charge enclosed and permittivity of the medium. Net charge enclosed and permittivity of the medium. Second, net charge enclosed and permittivity of the medium and size of the Gaussian surface C, net charge enclosed only. Last option, permittivity of the medium only. So I'll repeat this question. The electric flux through a closed Gaussian surface depends upon A, net charge enclosed and permittivity of the medium. Second, the net charge enclosed and permittivity of the medium and the size of the Gaussian surface. C. Net charge enclosed only, and D. Permittivity of the medium only. Okay. Those who are online now and those who are from class 12, if they learn first chapter, they can easily give the answer for this question. Which option will come? A, B, C and D. Which option should come correct here? Just now I taught many times, just now also I repeated, electric flux enclosed within a Gaussian surface is always depends upon what? Phi is equal to Q by epsilon naught, Q net. Okay, so here it depends always on the charge enclosed and the permittivity. Okay, so option A is the correct option over here. Okay, so tick mark the option A. You can tick mark the option A. Okay, copied. So now next question, write down next question. An electric dipole placed in a non-uniform electric field, an electric dipole placed in a non-uniform electric field can experience first bit, write down, a force but not a torque, a force but not a torque. Option B, torque but not force, torque but not force. C, always force and torque, always force and torque. Last option, neither force nor torque, neither force nor torque. Okay, I will repeat this question. An electric dipole placed in a non-uniform electric field can experience first a force but not a torque. B option, a torque but not force. C, always force and torque, neither force and nor torque. Very handy question. Okay, very conceptual based question is this. So here electric dipole is placed in an electric field, but that electric field is what? Non-uniform. Okay, just now we did one MCQ where flux is also continuous everywhere if the uniform field, electric field is there. Now here what? We have a non-uniform electric field. Okay, non-uniform electric field means the distance between the two lines may be not same. Okay, so suppose it is going from positive to negative. Okay, so this is the direction of non-uniform electric field. Now here if I placed a dipole, you can place like this. Okay, or if you want any position you can draw. Okay, so in our syllabus, even while teaching, we learn that wherever there is a uniform electric fields are there. Okay, and if you are keeping a torque, if you are keeping the dipole in the uniform electric field, okay, then there is what? Equal and opposite forces are acting. Because suppose this is, we have a negative Q, and if we have here positive Q, okay, and they are going from positive to negative. Okay, electric fields are going from positive to negative. So this negative wants to go towards the positive and this wants to go towards the negative side. So here the forces are acting, F1 and F2. But the problem is that here the electric field is uniform, so forces acting are there, that net force is nothing but what? Zero. Of course there is a torque generated. As it is uniform electric field, there is a torque generated. If non-uniform electric field is also there, there is a torque generated. But In case of non-uniform electric field, maybe force will not be equal to 0. Okay, maybe some force is present over there. But in case of uniform electric field, there is what? Net force acting on this dipole is always 0 because they are equal and their directions are what? Equal and opposite. So here F net is nothing but what? 0 when it is in a uniform electric field. But here this is the case where non-uniform electric field is there. So here what will happen? So there is a one force is acting in this direction, another force is acting in this direction. Suppose this is minus q, this is what? Plus q. Suppose this is 8 Newton and if suppose this is 2 Newton, so net force F net is nothing but what? 8 minus 2, that is nothing but how much? We have the answer 6 Newton is the force. Some force is present, that is for sure. Okay, in non-uniform electric field, that will not be 0. And of course, if it is keeping it in a non-uniform electric field also, there is a generation of torque. So here both force and torque are present. Okay, so option here, yeah, C is the correct option. Always there is a force and torque is present. As here also force is present, but that force will not become 0 because they are equal and opposite in direction. Okay, and here it is non-uniform electric field. So here there is a force is present and torque is also produced. Okay, so option C is the correct option over here. Some force is present over here. Getting this? These are very important questions. Huh? Copy or you can take mark the option C. If you want, you can draw the diagram and write down the things which I already wrote on the board. If you want, you can. Okay, everyone complete? Okay, write down. Next question. Okay, write down next question. An electric dipole consisting of charges. An electric dipole consisting of charges plus q and minus q, plus q and minus q, separated by distance capital L. Separated by distance capital L is in a stable equilibrium. Is in a stable equilibrium in a uniform electric field. An electric dipole consisting of charges plus q minus q separated by distance capital L is in a stable equilibrium in a uniform electric field. In a uniform electric field, full stop, the E bar electrostatic potential energy of a dipole is, the E bar electrostatic potential energy of the dipole is, options are given: A, q Q into capital L into capital E. Q into L into capital E, first option. Second option 0. Second option 0. Then third option minus Q L E. L and E is capital over here. And option last option D, that is minus 2 Q E L. Okay, everywhere E is capital and L is also capital. Okay, I will repeat this question. An electric dipole consisting of charges plus Q and minus Q separated by distance L is in stable equilibrium in a uniform electric field. The E bar electrostatic potential energy of the dipole is QLE, first option. Second option is 0. Third option is minus QLE and last option is minus 2QEL. So these are the options are given. Okay, here according to the given explanation we can try to draw the diagram. They are asking potential energy and we know that potential energy is nothing but minus P into E cos of theta. So here this is dipole and they are separated by distance capital L. Okay, and they are asking here the electrostatic potential energy and we know that U is equal to minus P into E cos of theta. Okay, so here they are asking what is the potential energy they are asking. So here we know that P is nothing but what, dipole moment, and dipole moment is nothing but what we have, Q into twice of L, but this twice L is given as what, capital L. So I replace this 2L by small l, capital L, so this will become minus Q into L. E will remain as it is and here cos of theta, but they are saying here stable equilibrium condition. So when stable equilibrium condition will form, so this is my electric field, positive and negative. When the dipole positive in this side and dipole negative is towards the positive side of the electric field, in that case I am getting stable equilibrium condition. So in this case theta in the stable equilibrium is 0. So that is the meaning of the stable equilibrium condition. They gave the condition, that means they indirectly mention the angle value of the theta over here. So this theta is 0. So here cos 0 is 1. So answer is minus QLE. So check which option is there. Option C is the correct option. Don't take option A in hurry-burriedly, okay, because that is positive and while derivation we derived that U is equal to how much, minus P into E cos of theta. Can you getting this? Understood how to solve this kind of questions? Copy this. If you want, you can. So write down next question. Write down next question. A square sheet of side A, is lying a square sheet of side A is lying parallel to xy plane at z is equal to A. At Z is equal to A, full stop. The electric field in the region, the electric field in the region is E bar is equal to C Z square K cap. C Z square K cap. Full stop. The electric flux through the sheet is first A raised to 4C, A raised to 4 into C. Option B 1 by 3 A cube C. Option B 1 by 3 A cube C. Option C 1 by 3 A raised to 4 C. And last option is 0. So I will write the options here. First is A raised to 4 into C. Then B is here 1 by 3 A cube C. 1 by 3 A cube into C. Third option is 1 by 3 A raised to 4 into C, and last option is here 0. Okay, last option is 0. So try to solve this question. Okay, so here these are the options. I think did you try how to draw the diagram? So here we have the square sheet is given, okay, and what are the conditions are there? Okay, xy plane. Okay, this is x, this is y, and this is z. That means this is I cap, j cap, and this is k cap. So they are saying here the square sheet of side A is lying parallel to the xy plane. Means what? Here indirectly we can take suppose this is what my xy plane is there. For like this I have a parallel. The parallel sheet I kept it like this. Okay. So I will try to draw the diagram. Can you able to understand? Check. So the plate is there, which is what kept parallel to this xy plane. Okay. And they are saying and each side of this square is nothing but how much? A. The side of the sheet is nothing but what? A here. Okay. And electric field is given. Electric field is nothing but they are saying CZ square K cap. Okay. K cap means along the Z axis. Electric field is there. Okay. Means electric field is what? Coming outward perpendicularly. That is the meaning of this K cap. And they are saying the electric flux through the sheet is. So we have to calculate the electric flux through this sheet. So I know that flux phi is nothing but what? E into S bar, correct? Or A bar into S bar. So E to I know, that is nothing but CZ square K cap. Now very important S. S I have to calculate. S is nothing but here square sheet of paper, and this square area of the square is nothing but A square, and that is also what? Parallel, that area vector is coming out, that is nothing but K cap. Okay. So here we can write CZ square into A square. K cap into K cap is 1. Okay, and here they are saying in the question itself z is equal to a. So I will substitute the value for z as a. So a square into a square, that is c a raised to 4 is nothing but what your flux, and that is also in the k direction, that is z direction. So here option A is the correct option. So don't make a mistake over here while calculating area. People are making mistakes over here. Okay, if you are taking something I cap, J cap, then entire answer becomes 0. That's what they gave, one more option, that is 0. Okay, because K cap into K cap in dot product is 1. Getting this? So copy this question. मी काय येणार नाही आहे समोर आता. मी येणार नाही. इकडे तुला काय काय करायचं सांगते. Okay, everyone copied. Okay, copied everyone. Can we move for the next one? Write down. Next question. A negatively charged object X is repelled by another charged. A negatively charged object X is repelled by another charged object Y. Another charged object Y A negatively charged object X is repelled by another charged object Y. However, an object Z is attracted to object Y. However, an object Z is attracted to object Y. Which of the following is most possibility for the object Z? Write down the option 1, positively charged, B, negatively charged, C, neutral or positively charged. Last option, neutral or negatively charged. I'll repeat this question. A negatively charged object is negatively charged object is X is repelled by another charged object Y. However, an object Z is attracted to object Y. Which of the following is most possibility for the object Z? Okay, they are asking about the object Z, and options are given here. First, positively charged, B, negatively charged, C, neutral or positively charged, D option, neutral or negatively charged. Okay, So here try to understand the question. What is the question? Negatively charged object X is given. Okay. So we will try to draw the diagram. So whatever the things are given, try to plot it on the paper and think on that. So you will get the answers. Okay. Or maybe you will get the triggers to think. So here there is one charged body, okay, and that charged body is taken as what here X, and this charged body is what negative. They are giving a negatively charged body X is repelled by another charged body Y. Okay, so there is another charged body Y, and this Y is repelled from X. It is repelling. Repelling means maybe this is also negative, no? Because negative repulsion means like charges repulsion, unlike charges there is a attraction. So this is also negative. Now after that they are saying, however, an object Z is attracted by the object Y. So there is what one more body they kept near to the Z, near to the Y. So Z is attracted towards the Y. Okay, attracted towards the Y. So which of the following is most possibility of the object Z? तो Z पे कौन से charges होंगे? Maybe this Z is what positive. So option 1 is the correct option. Option 1 is the correct option. Getting this? So mark that. Okay, copy that diagram. Okay, finished. So write down next one. Three charges Q comma minus Q, Q comma minus Q and Q naught are placed as shown in figure. Full stop. The magnitude of the net force on the charge Q naught at point O is I repeat this question. Three charges Q minus Q and Q naught are placed as shown in figure. The magnitude of the net force on the charge Q naught at a point O is. Options I will write first. A is 0. Option B is given root 2 K Q naught upon A square. And option C is 2K Q naught, 2K Q naught into Q divided by A square, and the last option they gave it as 1 upon root 2 K Q naught by A square. Okay, these are the four options are given. I will draw the diagram also. Okay, the diagram is also given. So This is the origin where Q naught is kept, that is test charge is kept. Okay, and we have here positive Q, and here they kept it as a negative Q. Okay, and here this origin means this Q naught to Q distance is A, and this minus Q naught to origin distance is also A here. Okay, both the distances are same here, and they are saying this is x axis and this is nothing but your y axis. Now they are asking here to calculate the magnitude of the net force. Okay, magnitude of the net force at point O. Okay, that is at Q naught. So this Q naught plus Q and negative Q, there is a force of repulsion because both are positive. So it is what repelling to this side. And there is an attraction between Q naught and minus Q. There is an attraction. Okay. So in between them angle is here 90 degree. So I have to find out net force. Okay. So what I will do, I will apply here Coulomb's law. So F is equal to K. Here Q due to minus charge, anyhow we are taking magnitude in this chapter, K Q naught upon A square, and second force due to this positive charge on O, so that is nothing but K Q naught upon A square. So now you can check, this is F1, this is F2, but both the forces are same, so can I write here F1 is equal to F2 is equal to F. So here the both forces are same, then we can take it as a F. But they are asking here net force, correct? So we have to take a resultant. So F net is nothing but square root of F1 square plus F2 square plus cos of F1 F2 cos of theta. Okay? So this is nothing but how much? F1 is nothing but I replace by F square plus F square plus this is 0 because cos 90 here 0. Okay, so you will get here twice of F square, that means root 2 into F. So root 2 F is nothing but K Q naught upon A square. Okay, this is what the answer. So now check the option. Yeah, option B is the correct option. Getting this? Can you get it? If you are applying the logic and concepts in a proper way, you will get the answers, correct answers for MCQ. Getting this? Copy this. Okay, getting this? Understood? So some questions are left. Okay. You can write down the last question, or else okay, we can continue tomorrow. Okay. So some questions are left that are also very important. I am expecting more people to join, but no one is there. So can someone say type a message in the message box? Who all are there? I want to know that. Can you type a message? Who all are there? Yes. Can you type a message? Prakrut. Okay, and okay, no problem, it's okay. I hope you understood the questions. MCQ, some few I covered, so remaining I will cover in the next session, that are also very important. Okay, so thank you for joining. I am ending this session.